Hey guys. All right. So I wanted to go over a couple of things before I started the notes today. Um, so let me get my brain straight. Monday, we did this operations of fractions assignment. If you haven't already finished, I think a couple of my online kids hadn't turned it in yet. So if you haven't done that, make sure you get it done, hit submit. Let me go ahead and show you on your screen when you open this up. For some reason, I just opened it for that one day, but I've changed it. I fixed it so it's open for everybody now again. So you should be able to see this. What you want to do is open this up into a new window, and then on your screen, you should see a blue submit button. When you click submit, it turns it in. And then once you've clicked submit, it'll say underneath the title right here, it will say turned in on, well, whatever day it is and the time and everything. So once that shows up underneath there, then you've turned it in. So make sure you've turned that in. That's our first grade for this unit, and will be the next grade I put into the grade book. Also, I have this factoring extra credit up here. If you want to do that, feel free, turn it in. I'll give you extra credit for this 9 weeks. Okay, so you're watching the video for today. The notes are posted, and I'm going to go through those. And then there's practice. So on this assignment, you're just going to choose 15 problems. There are 44 problems on this page. Don't do all 44. You don't have to do all 44. Choose 15 of them, okay? But don't sit there and just say, oh, these first 15 look easiest, so I'm going to do those first. Like, make sure you're doing some of these harder problems down here towards the bottom. They get harder as they go, okay? Make sure you're choosing some of these harder problems down towards the bottom because you're going to see some of the harder problems on your test. So if you've practiced them, then you'll know what to do. After this is due, then I might go back and post solutions. I'll post the answers so you can check yourself after it's due, okay? So that way you can check all the work problems you worked. And last thing, I now have posted, so you guys should see an exit ticket for adding, subtracting rationals. So when you open this up, this is a quiz style question. So last week, I asked you guys one day, what is one way that I can make my class better? And a few of my online kids said they would like a way to check themselves more often because I don't grade. I get participation grades for homework. I don't actually grade it. So I think that's a good idea, and I think I'm going to apply that for everybody. So my in-person kids are really doing the same thing every now and then. I have more opportunity to check their work because I'm walking around seeing how they're working problems. I don't know how you guys are doing until you take the test or until you turn in the homework assignments, and most of the time that's after we've already tested. So this will be another way for me to check and make sure you guys are progressing, and you get immediate feedback. So I'm going to show you the question. There's only one question here, and it is from the homework assignment. So you're going to subtract these two expressions, and you'll pick an answer. It will tell you what answer is correct. So this is going to be a grade. There's only one question, so you need to work the problem and try to get the right answer. You'll be able to take this as many times as possible, but remember, I get to see how many times you've taken it, and if you've just, obviously you're only going to take it the max 4 times, but if you've just clicked random answers and waited until you found the right one, then I'm going to be able to see that, okay? So use this as an opportunity to make sure you know what you're doing, okay? I am going to choose some harder, some problems that take multiple steps because I want to make sure that you're doing all of the steps. So make sure you do this, answer the questions, hit submit. This will be an easy, quick way for me to grade. And for you to check yourself along the way before we get to too far in and we've tested or turned in homework assignments or whatever. And this will also be a good way for me to see okay, do I need to reach out to you and figure out if we need to video conference or whatever. Okay. So now that we've got all that out of the way, let's look at the notes. I'm going to move myself. I'm going to keep myself on the screen and you can see me today. I usually go away. No, just go. No. Okay. My husband's telling me he's going to cook dinner. All right, so I usually make my videos for y'all while I'm sitting at home on my couch. So that's why I don't ever show you my face, because I'm in my own space and comfortable. All right, so here we go. Adding and subtracting rational expressions. If you are an in-person student and you are just not at school today's Thursday, then skip ahead in the video. We went through these notes already in class, but you do need to stick around and watch this part of the notes, okay? All right. So here we go. Adding and subtracting rational expressions. So we're now moving into a unit where we're dealing with rational expressions. This means we're going to have expressions with variables and terms, more than one term, in a fraction form. So in a numerator and denominator. So we need to understand how to add and subtract fractions first, and that's why I gave that operations of fractions assignment on Monday. So number one, these two are just regular fractions. They have a common denominator. To add something with common denominators, we just add the numerator. So we would do 5 plus 3 is 8, and your denominator stays the same. Then you can simplify this to 4/3 by dividing the top and the numerator and denominator by 2. I'm going to skip over to number 3. Number 3, we don't have like terms in the denominator, so we need to make like terms in the denominator. So I can make these the denominator the same by finding the least common multiple, and in this case, it's going to be 21. So I want to make the denominator 21. But whatever I do to the denominator, I have to do to the numerator. So on this first fraction, I'm going to multiply the denominator by 3 to make it 21. So that means I have to multiply the numerator by 3 as well. So 3 times 4 is 12 over 21, plus 2 times 7 is 14 over 21, and this is going to be 26 over 21. It's my final answer. Can't simplify that any further. Okay, so we know, hopefully, we know how to add and subtract fractions, normal fractions. So we're now going to look at fractions that have variables in them, like you see on 2 and 4, and then we're going to build them up from there. So on number 2, we want to get a common denominator. So the least common multiple between 5 and 6 will be, 5 and x are going to be 5x. So the first fraction, I want to multiply by x in the denominator and the numerator. So we'll have x times 4x, which would be 4x squared. And then we'll have that 5x in the denominator. On the second fraction, we already have an x down there. So to get that common denominator, I want to multiply by 5. So I'm going to multiply by 5 in the numerator and denominator. Whatever I do to the bottom, I have to do to the top. So we'll have 5x in the denominator, 30x in the numerator. So this, now I'm going to add across the top. So we have 4x squared plus 30. These are not like terms. Remember, to be able to combine these, they have to have the same variable and same exponent. And in this case, we only have one variable. So this, we're just going to write this as 4x squared plus 30 and divide that by 5x. And there's nothing further we can do here to simplify. I don't want to break this up into more than one fraction. I want to leave it as one fraction. So we're not going to simplify the 30 over 5x part of this. Okay, so hopefully we kind of get the idea. I'm going to skip number 4 on that section because I want to move on to these more difficult problems that we're growing up to. Okay, so to add and subtract things that have the same denominator, that have like denominators, you want to add or subtract rational expressions with like denominators by adding the numerator and then putting the result over the same denominator. So if they have a common denominator, do like you've always done, just like we did on number 1 up here. Add across the top, keep your denominator the same. So we're going to do that down here. I have I have a common denominator already on number 1. So that denominator is going to stay the same. And then in the numerator, I'm going to add all the way across the top. So I'm adding all of these things. So these are going to be positive. So I have x plus x. That's 2x. Then I have negative x plus 3y. So that is plus 2y. So in this case, in this problem, I see that I have a greatest common factor in the numerator, and I want to go ahead and take that out. So I'm going to factor out that 2. That's going to leave me with x plus y. And then I have 6x cubed y in the denominator. So now I can look at just the numbers. Because I'm multiplying everything in the top by 2, I can look at just those numbers and I can simplify that part of the fraction. So I have 2/6, and that fraction would simplify to 1/3. Well, I don't have to write the 1 in the top. That'd be multiplying by 1. I don't have to show that. So in the numerator, it's going to leave me with x plus y over that 6 is going to reduce down to 3, x cubed y. That would be my final answer. All right, so then number 2, again, our denominators are the same. So we have 8x cubed. Then we have x plus x is 2x. Negative 2y plus negative y is negative 3y. That's not going to simplify any. I can't factor out a 2 here because it's not common among all of my numerator. Okay, so now what do we do if we don't have a common denominator? Well, the first thing we want to do is find a common denominator. And then you want to multiply each numerator by what you multiply the denominator. So just like we've always been doing with fractions, whatever you multiply the bottom by, you have to multiply by on the top as well. And then add or subtract across the numerator and keep your denominator the same. I'm going to do number 3 here, and then I'm going to move on to the notes I've added on the second page of the slides. So number 3, my denominators are 2x and 6x cubed. So far what we've done is just multiplied each fraction by whatever the other denominator was. But in this case, I can do less work and still solve the problem. I can make my first denominator, this 2x, I can do something to it to make it look like 6x cubed. Then I don't have to multiply that second fraction by anything. So that's what I'm going to do. I'm going to multiply this first fraction by 3x squared on the top and the bottom. 3x squared. So 3x squared times 4x, 3 times 4 is 12. X squared times x is x cubed. And the denominator, 3 times 2 is 6. X squared times x is x cubed. Now I have a common denominator, and I didn't have to multiply the second fraction by anything. So what I did was found my least common multiple. So now I have 12x cubed minus 5x. Remember, these have to have the same variable and the same exponent. These exponents are not the same, so I can't combine them. And 6x cubed in the denominator. I do have a GCF of x in the numerator, so I'm going to go ahead and factor that out. That leaves me with 12x squared minus 5 all over 6x cubed. Then I can divide x by x cubed. And by my exponent rules, which hopefully we have all caught on to by now from the last unit, say that that's just going to leave me with 6x squared. And that would be the answer for that problem. Again, I want to leave this as one fraction. I don't want to break it up, so we're not going to simplify that 12 over 6 part. Okay? All right, moving on to the more difficult problems here. So number 1, we have x minus 4 over x squared minus 2x minus 8 plus x plus 8 over x squared minus 2x minus 8. So these have common denominators. I'm going to go ahead and add across the top. So I have x plus x, which means that is going to be 2x. And then I have negative 4 plus 8, which would be plus 4. And this is all going to be over x squared minus 2x minus 8. Okay, now I'm going to go ahead and factor the denominator. So in the numerator, I can take a GCF out and rewrite this as x plus 2. I'm going to factor the denominator to see if I would be able to cancel something out in the numerator. You're going to see as we work through these problems that some of these we're not going to factor when we have a quadratic. But if you see something that's easily factorable, like this problem, go ahead and factor it. See if you can cancel some things out. If you go to start factoring and it doesn't factor nicely, most likely you're not going to be able to cancel anything out. So just leave that quadratic in your answer and move on. Okay, so if we do our x, then we have a times c is -8, b is -2. So I have -4 and 2. So -4 times 2 gives me -8. -4 plus 2 gives me -2. So that means this factors in the denominator to be x minus 4 times x plus 2. So now I see something in the top and the bottom that's the same. And those will cancel each other out. Let me use a different color here. So this and this are the same. They undo each other. I'm multiplying and dividing by the same thing. So those undo each other. And I'm just going to be left with 2 over x minus 4. And that would be my final answer here. Okay, so then number 2, we have 6x minus 12 over 3x minus 6 minus 15x minus 16 over 3x minus 6. So I have a common denominator. I'm going to keep that the same. Then I have 6x minus 15x. So 6 minus 15 is going to be -11x. Nope. -9x. And then I have -12 minus -16. So that's -12 minus -16, which means I'm talking about -12 plus 16, which is going to be 4. So plus 4. So make sure you pay attention. This minus sign right here is subtracting that whole entire piece. So you need to distribute it through the numerator. Okay, so now let's see. I don't see how this could simplify any. We can't there's not a GCF in the numerator. And since I can't factor anything out of the numerator to be able to cancel anything in the denominator, I'm not going to GCF factor my denominator. So there we go. That's our answer. All right, let me change this paper really quick so that we see. There we go. Then we have number 3. Let me open this up here. Oh, that's not the right page. Here we go. Okay, number 3. Ooh, I've not been watching my screen. Has it been glitchy this whole time like this? That's not nice. Let me. All right, so number 3, we have 7a over 3a squared b plus 4b over 6ab to the 4th. So we do not have a common denominator. So what can I do to get a common denominator? Well, it looks like I would have to multiply. If I multiply this side by a, that would give me 6a squared b to the 4th. And then I can make this side look like that by multiplying it by 2b to the 3rd. I'm going to multiply this by 2b to the 3rd, right? So 2 times 3 would give me the 6. A squared stays. B cubed times b is b to the power of 4. 3 plus 1 is 4. And then in the numerator, 7 times 2 is 14. Then I would have a b cubed. And then 4ab. So this gives me 14ab cubed plus 4ab in the numerator. These are not like terms because that first term has a b cubed. The exponent's not the same. Over 6a squared b to the power of 4. I do have a GCF in the numerator, so I'm going to go ahead and factor that out. I think I can take a 2 out of everything. I think I can take more than a 2 out of everything. I think I can take a 2ab out of the entire numerator. So 14 divided by 2 is 7. A divided by a is 1. B cubed divided by b will leave me with b squared. Then I have plus 4 divided by 2 is 2. A divided by a is 1. B divided by b is 1. So I just have 2 in that second term. All over 6a squared b. Actually, I'm going to go ahead and factor out a 2ab in the denominator as well so that I can go ahead and eliminate those, cancel those out. So 6 divided by 2 is 3. A squared divided by a would just leave me with a. And b to the power of 4 divided by b would leave me with b cubed. So here I'm multiplying on the top. I'm multiplying and dividing by the same thing in the top and the bottom. So those undo each other, and we'll just be left with 7b squared plus 2 all over 3ab cubed. Okay? So on these problems, just kind of work your way through it. I recognize these things easily. I do math every single day. So just work your way through it. Take each step and think, okay, what do I know? What do these things have in common? What can I take out? And then can I take it out of the denominator as well? Okay, number 4, we have 4 over 5a minus 7b over 4a squared. So I need to get a common denominator. I think I'm going to multiply this second term by 5, and I'm going to multiply the first term by 4a. Okay, so 4 and 5, their least common multiple is 20. And then a and a squared, their least common multiple is a squared. So that's why I'm multiplying that first fraction by 4a, because 4 times 5 will give me 20. A times a will give me that a squared. And I'm multiplying the second fraction by 5, because 5 times 4 will give me 20, and I already have a squared there. I do want to say you can just multiply both fractions by the opposite denominators. That is okay. That will get you the right answer, but you're going to have to do a lot more simplification at the end because you're making bigger numbers, okay? But it's not wrong. So whatever floats your boat, whatever makes you happy. So 4a times 4 would give me 16a, and then 4 times 5 is 20, a times a is a squared, minus 7 times 5 is 35b, all over 4 times 5 is 20, and a squared. So this means I have 16a minus 35b, all over 20a squared. Let me write that a little bit nicer. I do not have any like terms because that is a b. So that's it. Did I write the problem down right? Yeah, I did. 7b. Okay. So that's it. All right, then we have number 5. 6 over 8a plus 4 plus 3a over 8. Okay, now we're going to try to be a little bit fancy here. When I was writing this problem out, I was like, ooh, I'm going to try this and see if hopefully we all understand it, because I think it's going to be the nicest way to go. I am going to multiply this fraction by a plus, hold on, let me think about what I said. Oh, a plus 1/2. I'm going to multiply the numerator by a plus 1/2. Okay. I need my denominators. I want them to look like 8a plus 4. So in order to get the 8a part out of this, I have to multiply 8 by a. In order to get 4 from 8, I'm going to take it and I'm going to multiply it by 1/2, because half of 8 is 4. So if I'm multiplying by a binomial, that means I have to distribute this through, right? I have to do 8 times a, and then I have to do 8 times 1/2. So that would give me that 8a plus 4. So I'm going to have 6 over 8a plus 4 plus, I need to distribute this. 3a times a is 3a squared. 3a times 1/2 is going to be 3/2 a, not a squared. 3/2 a. Then I'd have 8 times a is 8a. 8 times 1/2 is plus 4. So if I set this up, I have 3a squared plus 3/2 a plus 6 all over 8a plus 4. I'm going to keep going. I think we can simplify this some more. So I'm not 100% confident, but I'm going to keep going. In the numerator, I'm going to factor out a 3. So that leaves me with a squared plus 1/2 a plus 2. All divided by, in the denominator, I'm going to factor out a 4. So that leaves me with 2a plus 2. I'm not sure we're going to be able to cancel anything out here. We're going to double check that. I'm going to show you, like, sometimes you just have to keep going and try. Sometimes you do a little bit more work than is necessary, but that's all right. Ooh, no, it may work out. Okay. So we want a times c is 2. My b is 1/2. So what did I multiply to give me 2 and add up to give me 1/2? I want to say it's 3. Hold on. I'm going to grab my calculator really quick. The fractions always like get my brain doing weird things. None of these calculators have batteries. Let me try number 3 here. Okay. Well, that's in the wrong order. Okay. Oh, it's not going to work. So I would need to do 3/2 times -1. Oh, I'm subtracting. Hold on. Type it in wrong. Use the wrong negative sign. Okay. No. Multiply to give me 2. Hold on, guys. Bear with me. I should have thought this problem all the way through. Where's my... Oh, gosh. Calculator just died. There we go. Okay. Y equals... Let's do... Oh. Oh my gosh, y'all. Okay, so we have... That'd be... Plus... 3, 4.5, 5... No, this is not going to work. This is not going to work because that would give me a negative and a positive. It's not going to work. So this is probably going to be our simplest form. This is as far as we're going to be able to get it. Okay, Sorry, guys. I had to get my brain there on the right page. Okay. Number 6. So we have x plus 1 over x minus 4. Okay. I wanted to make sure that was an addition and not subtraction. I was like, oh man, did I mess up that whole problem? All right, minus x plus 1 over x squared minus 7x plus 12. I had to have written that problem down wrong. Oh, yeah, we gotta get common denominator. Y'all, now, hey, okay, sometimes I have moments too. Okay, so, here we go. Oh my goodness, what just happened? I'm having issues today. Cancel, don't connect to his TV. I'm really sorry, guys. This is right. We got to get common denominator first. Wasn't paying attention. All right, so to find a common denominator, the first thing I'm going to do on this problem is I'm going to factor this to see if I can just multiply x minus 4 by something to make it look like that. So I'm going to factor that piece. So that would give me a times c is 12, negative 7. So I'm going to go with 5, negative 5, and negative 2. So this is going to be x plus 1 over x minus 4 minus, no, hold on. I did it the wrong way. I'm going to do negative 3 and negative 4 because negative 3 times negative 4 gives me positive 12. Negative 3 plus negative 4 gives me negative 7. So that's x plus 1 over x minus 3 times x minus 4. Ooh, y'all. I've been giving that test all day today, so maybe that's just, my brain's just not in it, okay? All right, so now I can see I have this x minus 4 already, so I just need to multiply my first fraction by x minus 3. So I'm going to do x minus 3 in the top, x minus 3 in the denominator. I'm going to leave the denominator in factored form. So this is going to equal x minus 3 times x minus 4. And in the numerator, I have to distribute. So x times x is x squared plus x minus 3x minus 3. And then I'm still subtracting minus x and minus 1. So now I'm just going to go through and combine my like terms. So I have x squared, and then I have plus x minus 3x minus x. So x minus 3x is negative 2x, minus another x is negative 3x. And then I've got 3 and negative 1 is negative 4, all over x minus 3 times x minus 4. I'm going to go ahead and factor my numerator here. So that means I'm looking at what multiplies to give me negative 4, adds up to give me negative 3. I'm going to go with negative 4 and positive 1. So that means I can factor my numerator to be x minus 4 times x plus 1, all over x minus 3 times x minus 4. And I see that I have x minus 4 in the numerator and denominator, and that's going to simplify my answer. Those undo each other to x plus 1 over x minus 3. There we go. Okay, so I had a little bump in the road along the way there, but if you have any questions, let me know. So at this point, go ahead and go do maybe start some practice problems, kind of get the hang of it, and then come back and do the exit ticket. Again, if you have any questions, then let me know. This exit ticket is going to be a nice way for me to grab some quick grades throughout the 9 weeks, and it's a way for you guys to check, make sure you're doing the work right. All right, so you'll get immediate feedback. It'll tell you, yes, this question's right or wrong. All right. If you have any questions, let me know. Bye.